Hello everyone, welcome back to my channel. So in this video we will see about another kind of special concrete which is nanosilica concrete. Do watch my other special concrete videos which is in the concrete technology playlist. So I have talked about fiber reinforced concrete, lightweight concrete and also polymer concrete, etc. So moving on with this topic which is nanosilica concrete. So basically what is nanosilica concrete? So it is concrete in which the addition of nano sized silica particles is done to improve or to enhance the properties of concrete. So basically what are nano silica particles? So basically nano silica or nano sized silica particle is that where the silica, that is the silicon dioxide size, particle size is typically in the range of 1 to 100 nanometers. So that small size is the of silica particles are there. And when such silica particles are added into concrete, so these nanoparticles try to fill up the voids between the cement particles, and therefore your concrete becomes more denser and you have a more enhanced microstructure. Coming to the properties of nanosilica concrete, so what happens if you add nanosilica in making concrete? What all properties you can achieve is like improved compressive strength. So we all know concrete is very strong in compression. So if you try to add nano-sized particles, the compressive strength would increase more. Like significant increase could be there because of the packing density of the concrete, and obviously when you have a higher strength we can ensure a higher durability. So increase of resistance of concrete against the chemical attacks or acid attacks, chloride ion penetration can also be enhanced. And talking about workability, up to some extent the workability can increase with increase in nanoparticle addition, but after at a later stage what happens is that due to the more fine particles, like the nanosilica particles being more fine in nature, you may get a reduced workability. So at that time we can take the help of a super plasticizer. Better hydration, so one has to remember that more finer is the binder, more would be the hydration. So when we are using nanosilica as a partial replacement to cement, we can ensure that the as I've already told, the particle size of nanosilica is very small, like up to 1 to 100 nanometers, which is very small size. So the fineness is more. So when the fineness is more, the hydrative interaction of nanosilica particles would also increase. And as I've already told, since the particle size is very less, the density of the concrete improves, the packing density improves, and the microstructure improves. Thereby, it reduces the porosity because of the very fine particles, and also it increases the resistance to water penetration and also freeze and thaw cycles. And coming to the improved bonding, so obviously nanosilica can improve bond between the paste and the aggregate. It would enhance your ITZ, therefore resulting in better mechanical properties. And what are the advantages of using nanosilica in concrete is like, obviously we get a high strength and high durability, so it can be successfully employed for high performance applications, and reduced material use, so that when you want to reduce the size of concrete members, when you want to cast thinner sections or thinner structural elements, then we can with higher strength, like if you do not want to compromise for strength but you have to cast a thinner section, then we can take the help of this nanosilica. Eco-friendly up to some extent, because we are replacing cement up to some extent for with nanosilica, so therefore the reduction of carbon dioxide emissions can be lowered, which can lower the carbon footprint, and of course improve performance because of the denser microstructure. The resistance of your nanosilica concrete is better against chemical attacks, shrinkage and also cracking. Moving on to the disadvantages, the first disadvantage is cost. So nanosilica powder is little costly, relatively expensive when you compare with other, supplementary cementitious materials like fly ash or slag or rice cash. And handling and safety is also very important here. This is one of the major drawback of using nanosilica, because of the very fine particle size. It is in nanometers, right? So that can be inhaled very easily, so it can cause some serious health issues. So we have to be very careful when we are handling and when we are mixing. And coming to the mixed design complexity, because of the very smaller size and very fine size of the particles, dispersion and mixed design has to be looked very careful, because we may get workability issue, we may get consistency issues. So we have to be very careful when you are doing when you are replacing nanosilica in cement. And we require, because nowadays this has been a new material into concrete, so people use generally silica fume or micro silica, but using nanosilica has been relatively very new to the industry. So we do not have exactly the database, or we do not know exactly the performance of this concrete in long run, so that data is very limited. So this also could be one disadvantage of how much percentage replacement to be added in concrete. And moving on to the applications of nanosilica concrete, the first application is, as I've already mentioned in advantages, we can have it for high performance structures like bridges and high rise buildings, because it is having enhanced mechanical properties. It can be also used in marine and coastal structures because of its enhanced durability property. And it can be used in pavements and runways because of its resistance to wearing and tearing. And nanosilica concrete can be also adopted for repair and retrofitting of structures, like you can do it for grouting, you can use it for mortar, like you can use it as a filling material for cracks, etc. And industrial floors, because it is resistive against chemical attacks and having better durability, so it can be also used for industrial flooring applications. So that is about nanosilica concrete. Hope you all understood the video. Thanks for watching.